Okay, so question 4. You've got a 2x squared 7x plus 3, and all of that is being divided then by 2x squared plus 3x minus 9. So I suppose the idea here is that you can use the guide number above and below. Whatever way you've learned to factorize trinomials or quadratics, that's just what you're going to use, okay? So I'd say most of you probably went with the guide number. I might do one with the guide number and then just factorize the rest of it. So I'm going to take the top down separately. So I've got 2x squared plus 7x plus 3. The guide number this time is going to be 6. So if you'll see there, 6 and 1 will work to add to give me the 7 in the middle. So 2x squared plus 6x plus 1x plus 3. Factorize, factorize. So what will come out? We've got 2x leaving me with x plus 3. We've got plus 1 leaving me with x plus 3. So I'll have x plus 3, because it's common to both. You can see it there and there. So when I take out the x plus 3, I'm left with 2x plus 1. I'm going to take this and I'm going to sub it in on the top line. And I suppose what I'd expect is that something is going to cancel from the bottom. So it's up to yourselves how you tackle this. So I've got 2x squared, so I'm going to need a 2x and an x. Probably a 3 and a 3. Let's see. 2 by 3. Yeah. A 3 and a 3. I need one of them to be plus. I'm going to go plus and minus. Okay, so far?
Sorry for the interruption to class.
You can see there then.
Case is a pair of glasses in a black case. Could they drop them down to the chaplain's office right away, please? Thank you.
And there's your answer. Okay with that? Sorry, pen went. Yeah. Okay, next question then, number 8. So number 8, you've got x squared minus 1 all over 2x plus 6. Now, I suppose what you need to start doing is nearly have a feeling or have an inkling as to where you think this might go. That top line there, straight away, I'm thinking difference of 2 squares immediately. The multiplication symbol, I'm not going to put in the multiplication symbol, I'm just going to put in the dot. So I've got 3x plus 9 above the line. I certainly factorize out 3 there. And I've got an x squared minus 3x plus 2. So top line there, so I'm going to work down this way. Top line is x plus 1, x minus 1, all over. I factorize out the 2, leaving me with x plus 3, multiplied by, I'm going to factorize out the 3, leaving me with x plus 3. So there's some cancelling that can take place anyway. And then this quadratic here, what will it go to? Well, there'll be an x and an x. Now, some of you may do it this way. Like I say, you can still use the guide number method, but I'd safely say at this stage you're starting to see the patterns and see how it'll work for you. 2 and 1, it'll be a minus and a minus. So things will, I suppose, I'm going to use the word cancel away, but I'm going to have a quick chat to you about that in a second. So that'll go, that'll go. Anything else? Yeah. Now, rather than, I suppose, just to facilitate the conversation on cancelling, things don't cancel in maths as such. They don't just disappear. What actually happens is I can take this x plus 3 and I can move it. I can change its position in my expression. So I'm going to rewrite the whole expression. X plus 1, there was a 3 in there, and then at the end there was x plus 3. And that's all divided by 2. There's an x minus 2. And then at the end there, I'm going to put in my x plus 3. And just so as that we're clear, what's actually happening there is the x plus 3 is dividing into the x plus 3, leaving me with a remainder of 1. Very often people think that those kind of things, that it goes to 0 or it just disappears or it vanishes. It doesn't. They divide into each other, leaving 1, and then when those 1s are multiplied back into everything, well, they just leave it the way it was. Okay? But sometimes so that you understand what I suppose cancelling is, rather than just what maybe so long as you don't think it goes to 0. You can tidy that up any which way. I'll just pop it up here. You might say 3 over 2 and then x plus 1 and have your x minus 2. Okay, so I'll keep going anyway. I'll take questions in a few minutes. Let's say number 9. Let's say number 9. So x squared minus 121, again difference of 2 squares, all over x squared minus 4. Straight away you'll probably spot that difference of 2 squares again, multiplied by x plus 2 all over x plus 11, and you can nearly see immediately what's going to happen there. So I'll have x plus 11, x minus 11 all over x plus 2, x minus 2 times x plus 2, I'll stick it in a bracket just for handiness sake, x plus 11. And again, so things will start to cancel, but I say the word cancel on the understanding that you now know what's actually going on. So gone, well not gone, but you know, divided. So your final answer, x minus 11 all over x minus 2. Okay, so I'm going to take a little jump down. Your homework was to 12, but I'd safely say the rest of it was okay. I'm going to take a little jump down, and I'm going to talk to you about question 16. Fairly straightforward question, but just it'll preempt what I'm going to do next. So question 16 says 2 all over x plus 3, and you've to subtract from that 1 over x plus 4. So what you're going to do, or your tactic, is you're going to get a common multiple. Now you notice I'm not saying the lowest common multiple, because I don't know whether what I'm going to write down is the lowest common multiple or not. It would depend on the value of x that you put in. So a common multiple that I can be guaranteed will be a common multiple will be x plus 3 and x plus 4. And then what you're going to say is, well, bottom into bottom, drop down what's above. So if I take what's here, x plus 3, if I were to divide it into the bottom here, they'd cancel for me, and I'd be left with x plus 4. So I'll say 2 times x plus 4 minus, and I know I've made a little bit of a mess of that, but hopefully you understand. Now you'll say bottom into bottom, so the x plus 4, so this time I'd say x plus 4, and of course it would cancel, and I'd be left with x plus 3. So 1 times x plus 3. Just to tidy that up, so I'll stick it up here. It ends up being 2 x plus 4 minus 1 x plus 3. Don't forget to put in your common denominator. So x plus 3 and x plus 4. You can tidy that up then, so you'll have 2x plus 8 minus x minus 3 all over x plus 3, and finish it then. I don't expect anybody has any. That's why I'm going through it quite quickly. I wouldn't expect people have much difficulty with it. You may not have learned it the way I've just described it, you know, using that phrase bottom into bottom, drop down what's above. What you may have learned was put in the common denominator, which is here. Okay, sorry, that green didn't come up too well. I'll put it in red again. You may have used, put down the common denominator, which is here, right? And then this idea of crisscross. I don't like the phrase cross multiply, so I won't use it. So a little bit of crisscrossing. So you'll go from there to there and multiply, and then from here up. And you can see that it's the same thing. You've got 2 by x plus 4, which is here, and you've got your minus, which drops down, and then 1 by x plus 3. It's essentially the same thing, but I suppose I don't like the phrase cross multiply, so I won't use it. So I don't think there's anything too difficult about what I've put there. With that in mind, I want to, I suppose, take a look at, I'll need a new page, question 19. So question 19, it looks, oh no, sorry, I won't. Question 22 is what I want. So question 22 there. Might be it might be a bit dull, but we'll see. I might try it an awkward way. What have we got here? We've got x squared minus 3x plus 4. Sorry, minus 4. If I was better on that, I could delete that. X minus 1 all over. Okay. I suppose to tackle this question, probably what you should do is factorize the two bottoms. See if something will cancel off for you. Okay, so that's what I'll do. I don't know where it's going to go, but we'll see what happens. So x minus 3 all over. X, you're going to need a 4, you're going to need a 1, you're going to need a minus and a plus. X minus 1. Stick in your brackets. You're going to need a 2, a positive 2, and a negative 1. No, sorry, the other way around. Positive 1 and a negative 2. So that's what we're left with, and again, it looks a little bit awkward. Now, if you look at its structure, though, even though there's a whole bunch of brackets here and here, and it looks awkward, essentially you've still got a fraction minus a fraction. That's all you've got. So it's still going to be tackled. If you just recall the question we did a moment ago, we said it was 2 over x plus 3 minus 1 over x plus 4. So the structures are still the same, so you're still going to handle it the same way. You might have to be a little bit, I suppose, clever about how you do it, maybe to reduce some of the workload, but it's still going to be the same thing. I'm still going to create a common denominator, right, and then use this idea of crisscrossing, or bottom into bottom, drop down what's above, whichever way you prefer. So I'm going to create my common denominator, or common multiple. X minus 4, x plus 1, x minus 2. And you'll notice I haven't put in this extra x plus 1 here. I don't need to, because whatever number that is still going to divide into my common denominator. So I don't need to put x. Whenever you've got things doubling up like that, don't put it in 3 or 4 times or even twice. It's already there for you. So hopefully now you'll kind of get an idea of why I say bottom into bottom, drop down what's above. So, or crisscross. I'm going to stick with the bottom into bottom first. 1 second. So, I'm going to take everything that's here, and I'm going to divide it. Now just in my head, or I could do it over on the side. X minus 4, x plus 1. Gone, 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 gone. What will I put in? It will be x minus 3, so that's dropping down from above, multiplied by what I'm left with here, x minus 2. That okay? So I'll tidy it up. I know when it looks very messy. So I suppose, what am I left with here? I'm left with x minus 3, x minus 2, and all over I've got x minus 4, x plus 1, x minus 2. My minus will drop down, and I'm going to start the process again. So this time, I'll try it in red, see how it goes. I'm going to bring this down, so my division will take place here. I'll just rewrite that. So I've got x minus 4, x plus 1, x minus 2, and into that I'm dividing x plus 1 and x minus 2. Gone, 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 gone. So this is what I'm left with. Don't forget to drop down what's above. So this bit is going to come down. Don't forget your bracket. And that's it. You'll multiply out the top. You might decide to factorize it. Always worth taking a look along the top. Is there a bracket that's common to both? In this case, no, there's not. So I'll just say etc. for that one. So you can finish that one off. Yes? The second line. I'll just put this in yellow. Sorry, I'll just stand up. Are you talking about here? Okay. Here and here? Here? I'm going to keep going. I don't know what you're asking me, so we'll sort it out when we stop. Is that okay? Alright. Do you want me to do another one of those? Yeah, okay. Let's see if there's another interesting one. Kind of. Oh yeah, okay. This is question 17. So this question maybe not as messy to write out. X minus 3, 2x all over x squared minus 9. I'm going to do this question in two different ways. So I'm going to do it my way first of all, which is bottom into bottom, drop down what's above, and then I'll do it, if some of you are struggling with the idea a little bit, I'll show you an alternative. So the first thing I'm going to do is say that that's 3x minus 3, 2x, x plus 3, x minus 3. So hopefully you're okay with that. Common denominator. I'm not going to repeat things, so I'm only going to put in 1x minus 3 and 1x plus 3. Well, and I'm going to start the process now. Right. So bottom into bottom. So I've got my x minus 3. I'm going to divide it into this line. I'm going to start doing this in my head now. When I divide it in, I'm left with x plus 3. And I'll just drop down what's above, which is my 3. Okay? Let's try this. Oh, it works. Drop down the plus. So I'm going to start again. But this time I'm dividing in all of what's there, so the x plus 3 and the x minus 3, into everything that's below there. So that'll actually just go in once and drop down what's above, which is my 2x. And now tidied up a little bit. 3x plus 9 plus 2x all over x minus 3, x plus 3. Generally I say to students, don't bother multiplying out the bottom. Okay, you're usually better off leaving it the way it is, because when the question develops, very often more stuff will divide off for you. What do we got here? 5x plus 9. Okay. So there's, I suppose, one way of tackling the question. Now, if you're going to use the crisscross method, so I'm going to redo it, if you're going to use the crisscross method, well, then you have to put in all the denominators. So I'm going to rewrite the question to show you what I mean. And there's no harm in you putting in all the denominators. It just means you have to do a little bit of factorization at the end. So this time my denominator is going to be x minus 3 and x squared minus 9. And hopefully you understand that x squared minus 9 means x plus 3, x minus 3. So I'm putting in all three brackets this time, as opposed to only putting in 2. So if I use the idea of the crisscrossing, well, that means it will be 3 by this, and then x minus 3 by 2x. So that's what I'm going to do. 3 by x squared minus 9 plus 2x by x minus 3. I'm going to do what most students do in this case. They multiply out. They tend to multiply out the top line as opposed to factorize now. So I'll just do what most students do. So 3x squared Okay, I have that right, don't I? Okay. Now the problem with this, like this is correct, okay, but from a marking point of view, very often the questions will say factorize fully. So even though this is correct, it isn't factorized fully. Or sorry, it will say and simplify fully is what I should say. So it's the correct answer. It's the same as what's over on the left hand side, but it isn't as simplified as one could make it. So what you'd be expected to do there is take that top line and factorize it. So it'll be 5x and presumably x. That's going to be a minus 3 plus 9. Just check if that works. That's 15 and 9. Yeah. And if you have a close look there, you can actually see the x minus 3s. They can cancel off for each other, divide into each other, leaving 1. So you'll end up with 5x plus 9 all over. And I just to show you that it's the same. That denominator there, the x squared minus 9, that's the difference of two squares. So x plus 3, x minus 3. And of course, the answers are both the same. Okay. So I don't really mind which way you do it, but you need to pick one way and be very clear that that's the way you're going to do it, because as you can see, particularly when there's common factors in the two terms, if you're not clear on the method you're going to use, and you're going to use the crisscross but not put in the extra factor, it won't work. Okay, so I suppose it's very easy to get confused, and that's sometimes what happens to students. They get confused with all the different methods they've seen. There's the two methods that you can work with. You need to pick one of them and run with it. Okay? It will still work for all of the other things that we're going to do. We can tie it in with equation solving as well. Okay. Now I know I'm going on a bit. Let me just take this off. I'm going to do one more question for you. Don't forget, lads, you can scan forward in the video and back, so you don't have to listen to me the whole time. I'm going to do one more question for you because I think it's kind of interesting. Let's take a look at the likes of question 30. So question 30 is 1 over, sorry, x minus 1 over x all over So students tend to do all sorts of fantastic things with this kind of stuff. They really do. Like sometimes they cancel the x's and I don't know, do loads of stuff. I suppose the problem, if I were to pick the problem with this here, it's what's below the line there. Okay? And this is called a compound fraction. It's a fraction within a fraction. And I'm going to show you two different ways to deal with this kind of a problem. So one way, based on the method that we've just seen, I'm going to take the top line, which is x over, sorry, minus 1 over x. I'm going to stick that over 1 there, of course. And what I'm going to do is I'm just going to simplify it. So it will be 1 minus, it'll be x minus 1. Using the process that we saw a moment ago. So one, bottom into bottom, so 1 into x is x, x by x is x squared. That was the test. And then bottom into bottom, so x into x goes 1, 1 by 1 is 1. I'm going to take the bottom part of it, so that's the top. I'm going to take the bottom. It's 1 plus 1 over x. I'll stick that over 1. Common denominator is going to be x. I'm going to repeat the process, bottom into bottom. In this case, you could use the crisscross without any difficulty, but 1 into x is x, so that's going to be x plus x into x squared is 1, x plus 1. And now I'm going to put them back together. Okay, so the top line was here, so it's x squared minus 1 all over x, and that's all over. And you'll notice that I make the main division, I make it very obvious, and that's all over x plus 1 over x. Division of fractions, hopefully you remember, invert and multiply. So I've got x squared minus 1 over x multiplied by, and just take this one and flip it over. Is that okay? Now I'm going to take out that multiplication symbol because we don't use multiplication symbols really anymore. I'll just put in a dot. So it's being multiplied. Of course you can see that's gone, that's gone. The top line, this bit over here, difference of two squares. So x plus 1, x minus 1, all over x plus 1. So in fact, the whole thing shrinks down to just x minus 1. I'm going to show you another way to do it. You don't need to write it down, it's on a video. You'll have it forever. I'm going to show you another way to do it. So the exact same question. Now this is the way I prefer. I like this way to do it, right? So same question, wherever it's gone. I've got x minus 1 over x, all divided by 1 plus 1 over x. So, when it comes to fractions, if I multiplied something by 2 over 2, essentially I'm multiplying it by 1. 3 over 3, 4 over 4, 5 over 5, 10 over 10, a million over a million. Okay? X over x, y over y. So I can multiply in x's and y's, or numbers, or combinations of both, provided I multiply the same thing in above the line and below the line. I'm not changing its value, I'm just changing how it looks. So, what I want to get rid of here is I want to get rid of the x that's in the denominator. So what I'm going to do is I'm going to multiply by x over x. I'm going to stick a bracket here and here. What's x over x? 1. Now you might be just looking at that and saying to yourselves, that looks a bit funny. Just to make sure you're okay, again I'm going to make this a bigger division. That's really x over 1 and that's really x over 1, just in case you're a bit flustered with the fractions. Multiply in the way you always would and see what happens. Do the first bit there. X by x is x squared, and then it's this second bit here that I'm interested in. What's x multiplied by 1 over x? It's just 1. All over x plus 1. And of course then you can do your difference of two squares to give x minus 1 as your answer. Okay. I like that. Okay. If I had a choice between using that method and the previous method, I would always go for this one. Not always going to work, but you'll find that the questions that you're given are usually set up so as that you'd be able to multiply above and below by something that will cancel everything off. Okay, that's it.